Welcome to today's webinar. Thank you for joining. So as Martin mentioned, we will talk about the GeoSLAM best practices along with some of the new features. And we will use the one building as a real scan example of the scanning project, which you can see on the picture. It's the house that has been scanned with the ZEB Locate and terrestrial scan. And later on, Martin will also show you how to register the two different point clouds together in Draw, right after we speak about the best scanning practice. So the webinar's agenda covers how to approach the project, meaning selecting the suitable tool for the job and considering clients' requirements. We will talk about the capture practice and data accuracy checks. Since we are using ZEB Locate as an example for the building scan, we will also explain a little bit more about the processing workflow of the system and possibilities of Hub and Draw, including some of those new features. And at the end, we will show the output and deliverable from the scan, which was created in Revit. So to start with, selecting the right tool for the job. What type of project is to be scanned? In this case, we had a house that needed to be scanned inside and outside as well. The house has 3 floors, and we were provided with a drawing in advance, which is a common application for the measured building survey to find out what a true building is compared to its design. And often, architectural floor plan documentation is not accurate or not even available when it comes to some older buildings. The as-built representation is also a key information for the building life cycle, and knowing exactly what we have will help us to maintain, manage, or modify the building. What are the customer requirements? Those can often range from the capture time, as the access to the site might be limited, through density, accuracy, or georeferencing. This is also why we will show how to process and merge a combination of mobile and terrestrial scans. What do we want to deliver? We will look at creating floor plans later on in Draw and further utilizing Draw plugin for Revit models. And which mapping system to use. This can often depend on the job requirement. The range of ZEB family includes ZEB Revo, seen at the bottom of the picture. This has the highest IP rating of 64 to perform well in challenging, humid or dusty environments, and it is post-processing based. ZEB Revo RT that shows the scan in the real time on your device and produces ready point cloud right after scan. Both ZEB Revo and RT capture up to 43,000 points per second and have a range of 30 meters. ZEB Horizon, on the other hand, has a range of 100 meters, can collect up to 300,000 points per second, and is very modular. It can be used handheld or in the installation with Discovery, which includes 360 camera. If the point cloud needs some visual reference or colorization, this is something to consider, the selection of the camera. Or another system, one of the latest additions, ZEB Locate, where Horizon can be also used with GNSS receiver for georeferencing of the point cloud data. And I will talk a little bit more about ZEB Locate in relation to the given building scan. Nevertheless, things to consider before the scan is the capture route preparation, if possible, knowing the place where you can start a system and make sure there are enough features in the environment. For each ZEB system, a loop closure is required. Some bigger projects than 20 or 25 minute captures might also require to split the surveys into several scans. And in general, a short project planning in the office can help to save time on site. So how ZEB system works? This applies to all ZEB family products. We have a strong SLAM algorithm, where SLAM stands for simultaneous localization and mapping. And we utilize both laser scan data and IMU, inertial measurement unit information. When the system starts and it sees some objects around it, it will be able to know where it is in space as you move around those objects. This is the 3D feature recognition. Features are objects with some unique geometry, at least 1 meter in size, and within specified range of the system. For example, the maximum range of horizon is 100 meters, and feature should be no more than 40 meters away. Based on the features in the scan area, the result is a registered 3D point cloud that doesn't need any further matching. So the real advantage is speed with which you can capture the data. You don't need to be static, and you can capture also in any GPS denied environments.
So can you go one slide back, please?
Of course.
Doing here a comparison to a terrestrial scanner. You need to remain static if you have a terrestrial scanner. So the advantage of a mobile mapping system is the speed. I mean, you reduce your amount of time you are on site like around 1/8 or something. So if you scan with a terrestrial scanner like 8 hours, it would be possible to capture the same site with a GeoSLAM device or a SLAM-based scanner in around 1 hour. But this is of course depending on how the site looks and how many scans you are doing with a terrestrial scanner, and if you're scanning with color and so on. So you have the advantage of the speed, but people always complain that the accuracy is very bad in comparison to a terrestrial scanner. But what people often forget about that is that a terrestrial scanner, there are two accuracies which are playing or are coming into play. This is one time the accuracy of the scanner itself, which is around 1 millimeter. And this is what people always say. My SLAM is like, 2 centimeters to 20 centimeters. And my terrestrial scanner is 1 millimeter. It's so much better. But people often forget that there is a registration error of the terrestrial scan as well. So you don't have 1 millimeter, it's 2 millimeters, 5 millimeters, or 1 centimeter. Or if you have scanned very poorly with a terrestrial scanner, you can have 20 centimeters yourself with a terrestrial scan. And these are the two things you have to compare. You have the single point accuracy from a terrestrial scanner, which is 1 millimeter, and for a SLAM-based scanner, depending on the scan head, it's 5 millimeters to 1 centimeter to 2 centimeters. But then you have the global accuracy, which is the accuracy of your scanner plus the registration, or in this case, of your SLAM and the single point accuracy. And these can be very identical depending on how poorly you scan with a terrestrial scanner. I wanted to add that.
Yes, thank you for pointing that out. I'll move to the next one.
And here, as an example as well, or to make a comparison to a terrestrial scan as well, you can have a good environment to scan with GPS, and you can have a good environment to scan with a laser scanner. So as mentioned before, you need these features in your point cloud to be able to have a very good SLAM result, meaning there are objects in there. If you just have empty rooms, this will work out as well. But if in the rooms are certain things like tables or cupboards and other stuff, the SLAM is normally working a lot better. And the same with the GPS. I mean, the more satellites you see, the better your localization of your GPS, right? And the more objects you see with the horizon, the better the environment and the better the SLAM. And the same with terrestrial scanners. The more features you see if you're scanning with spheres or checkerboard targets, the better the result. Meaning, in this case, we have a very good environment if we are in a cave where we see in all directions, or if we are in rooms where objects are in there. But on the other hand, if we go to the next slide, there are very bad environments where the GPS, for example, where the position of the GPS is very bad because you don't see so many features anymore. And the same for the SLAM approach. If you are in a flat surface out in the fields and there are no objects around you except the bottom, the floor, then the SLAM is not working very well.
This is something that people should have in mind as well, that sometimes the features can be behind you. For instance, if you're walking from one room through the hall, and to improve the scan accuracy or reliability of your data, you can just keep pointing to the site where the system can see the best geometry of those features. So moving to the scanning practice. So what is the best capture practice for indoors and outdoors? For indoors, you should plan where to start a scan and ideally to be able to approach this start location from the end, from a different direction, and perhaps also to plan to open doors that will make it easier to loop in each room. Also, transitioning between environments should be done smoothly, meaning for walking through the door, it is recommended to slow down, walk sideways, and allow the system to features in both rooms rather than rushing through and losing this connection between the rooms. For outdoors, Horizon is a general great system to use outdoors for its 100-meter range. One thing to remember is still to make those local loops around a group of features like trees or parked cars. The loop diameter could be between 5 to 10 meters, and start and finish location also need to be the same, and you need to have the system facing the same features like the buildings or the trees. So how often should you make those local loops? We would normally recommend every 100 to 200 meters, there should be some kind of a smaller local loop around a set of features. We would also recommend for one scan to be within 20 to 25 minutes. And if the projects are much larger, the multiple scans can be later on merged. What is just required is around 20 to 30% overlap that is rich in features as well to merge the scans in the post-processing stage. Now, the loop closure is important in order to achieve the best possible scan accuracy. So in this example, start and finish always, if possible, should be approached from different directions. And making use of any rooms, any openings to be able to make those local loops rather than just walking in the straight direction. Also, as Martin mentioned before, if you don't have enough features, you could always improve it by introducing some features, bringing some boxes with you, opening the doors, just making the environment a bit more unique rather than having the open halls with the blank walls. The loops can also be closed vertically. For instance, in the multi-story buildings, it's recommended to make use of more staircases, as seen in the picture. So this is a short video, hopefully you can see it, of the scan of the house. And you can see the outdoor scan. This is the trajectory. You can see the 3 floors there of the ZEB Locate capture. I would say this is not really the best example because you would really want to have a good, even more scan done outside of the house in order to georeference the point cloud. And next, if I just move a little bit backwards, you can also see that only one staircase was available in this house. And saying that, to improve the accuracy, you can make use of the range of the system. If you start a scan outside first, then you can see a lot of features around. In each floor, if you have a balcony or the window where you could allow the system through to see through, it will see the same features outside, trees, parked cars, and this way it will also count as a loop closure in case you don't have the multiple staircases available. What it also shows is trajectory colored by SLAM condition. So blue is good. That indicates that it had a good environment, good features, good walk, and red is generally bad and gives you an idea if something needs to be improved or any processing parameters needs to be changed. Another accuracy check that can be done is by looking at the point cloud data colored by time. Red and blue represent the start and finish of the scan. So if you look at your starting location, you should see very well aligned scan without any mismatch with looking at those colors. So all this information, including the trajectories, is processed in GeoSLAM Hub. It's a software that allows you to process the raw data from any ZEB products. You can also merge multiple scan captures, adjust the processing parameters, or use GeoSLAM Draw for further workflows that Martin will later show in the practical example. The latest version of Hub is 6.01, and some of the newer features include a new processing bar, so you can see the stage of your data better. For instance, if you're colorizing the point cloud with the ZEB cam. There is also a configurable data folder that you can set up your own folder where you want to process the data. So it doesn't have to be restricted to C drive anymore. And also you can specify how many data sets you want to process at once in the processing queue. This means that you can just drag and drop all the captures into Hub, and depending on your computer parameters, you can, for instance, set up that you want to process 3 data sets at a time. And since we selected Locate for this house scan project, let me tell you just a little bit more about this latest edition. Horizon can be used with any GNSS receiver rigidly mounted together, like for instance on the backpack on the screen. And the system can be used for any applications where georeference point cloud is a need. This often includes management, asset management or maintenance applications. So how to scan with Locate? Showing the same example of the house. The system, to start with, needs good GNSS, but also features. It needs to be started outdoors, and majority of the scan should have good GNSS signal. The system also needs to start and stop at the same place, just like any other ZEB product. And in this video example of the house, you could just walk around the building, pop inside, and if you lose GNSS signal, this is fine as long as you have a good GNSS recording from the outside capture. Some of the key points of the system. Our tests show several centimeter accuracies against the known control points. The point cloud is transformed to GPS trajectory. This is a rigid transformation, meaning that GPS can be lost, and the best capture practice for Horizon also applies to Locate. And the workflow is as follows. You walk and scan with Locate, process Horizon data in GeoSLAM Hub software, which gives you the process point cloud. And then ZEB Locate Processor will register the point cloud with a GPS trajectory and will give you the georeference point cloud as a result. So just a screenshot from the ZEB Locate processor, where you can see that the input required is GPS trajectory. You can accept it in different formats. Horizon trajectory that's processed from Hub, and Horizon point cloud also processed from Hub. The lever arms, X, Y, Z offsets between the Horizon scanner and GNSS antenna also need to be specified. And when it comes to results, the point cloud will be saved in the same folder as is the input point cloud for the ZEB Locate Processor. So in case this is selected within the Hub data folder, you can then from Hub go directly into Draw and select the registered point cloud to start with. So I will stop here, and Martin, I think you can take over and show the processing steps, if all right.
Okay, all right, then I will take over. So now you should see my screen, right?
I can see it all right.
Okay, perfect. So oh, it's still in German. I will switch it to English after the processing. Yeah, you clicked in GeoSLAM Hub on Create My Draw project, please, and then you open your Draw project, and your standard views are calculated. I think we missed here one slide, which I wanted to include before starting with that.
Do you want me to go back to Draw slide?
This is this slide here. So GeoSLAM Draw 3.5, I will show my stuff in GeoSLAM Draw 3.5, which is the upcoming version. It's currently tested. We don't have a release date yet, but just to give you some overviews here. Everybody who owns a GeoSLAM device, a ZEB Horizon, a ZEB Revo, will get GeoSLAM Draw with the start package. So everything I will show now, you are able to do directly yourself. Since I will combine GeoSLAM Draw data or GeoSLAM data together with Faro data, if you want to register the Faro data directly in Draw, you will need to upgrade to BIM, Mining, or Pro. Then you are able to register your point cloud in Draw directly, and you don't need to do that in Faro Scene or in any other software, but you are able to do it directly in Draw. But in this case, I have only start. I've imported an E57 point cloud, which was registered, and it's Faro data. And then we will talk a little bit about other functionalities which we have improved, like the vectorization, the view direction of panoramas. So if you are using ZEB Pano, that you're able to see in which direction you're currently looking in the panorama in layouts, and how these are looking. I will do that with the Faro scan data, because there you have panoramas in the terrestrial scans, but just to give you here an overview how this will look if the version is out there. All right, so it has processed. I wanted to switch the language to English. Yes. All right. So now here we have our data, and we want to combine them, combine that with Faro data. So this point cloud here is already transformed. You see here the coordinates. It's in world files, since we used ZEB Locate with the GPS antenna and walked outside. And as Ivona mentioned, to have the best practices in Hub or in walking around in the loop closure, at the first floor, we always try to take the ZEB Horizon and hold it out of the windows, so we were able to make loop closures from the outside to the inside and have a better loop and a better SLAM. So how are we going to do that, the combination? Since we use Faro scans in the outside to have a very good measurement of the facade, we used spheres in there, and we will use the spheres in Draw and in the Faro scans to combine both projects via a 6-parameter transformation. So first we need to locate the spheres. If you have made a plan in the field where the spheres are located, this is a lot easier. So for example, we can see here is a sphere. So I will now create some sections where the spheres should be. So we see them in a section. and then we are able to click them in the sections. And at least you need normally 3 different spheres to make the transformation, as you all know. But to get a better result, we will here use 5 different spheres. So here you can see the first one. I use the sphere tool, and then I click here on the sphere, which I can see very clearly, and then it is found. And I'm going to do that with the other spheres here as well. And here we have 2 more. This one.
Would you be able to show later on where to set the diameter of the sphere as well?
Yeah, we can do that. Normally everybody's using 145mm spheres, but if you happen to have another sphere size, then of course you need to set another diameter. The easiest way is to go in the settings yourself and go into the registration tab, and under features you have here the diameter, and here you can choose another diameter, or you can insert another diameter by inserting a comma and another number. And now you see here I have the 500mm, and I would be able to check that. And then if I use this tool here, it will try to search for 500mm and 145mm. Since we are doing the transformation, when doing a 6-parameter transformation and Helmut transformation, you always need to know which spheres or which features are identical. And to make it very easy, we can just rename them here. So this sphere here, for example, is the one at the back door. So let's just call it back door. And let's use these 2 here as well. So this one is the entrance to the cellar. And this sphere here is the entrance, is the front door. So now we have here the names, and we are all set with the GeoSLAM project. All we need to do now is export this features in a text file. So we have the coordinates of the spheres, and then we are good to go. So I open the transformation calculator here, because here we have all the coordinates, and here again you see that we are in a global coordinate system, and all I need to do now is right click and say export scan points, and we don't want to use an XYZ but a TXT file, so we are able to have the names in there as well. So I save that, and with that we are already finished with the GeoSLAM project, and now we just open the Faro scans. So in the Faro scans, you see they are not georeferenced, and you have here everywhere the scan position where a green dot is. There was a scan set, and in this case, we just need to find the same spheres and mark them. So I open a panorama view because it's a lot easier to find them in there. Here we have our backdoor sphere. We can name that directly, so we have the correct name, backdoor. Then we used this one here. All right. And then I forgot one. The one in the window, if you remember. So it's here. And now the one from the front. Open the panorama. It was this one. This is the one to the basement. And this one, which is the one to the front door, as you can see. All right. So now I open the transformation calculator again. And you see here I have the spheres in there. Now they are in the local system of the Faro scans. And now I add the one from the GeoSLAM scans directly to there. So this is the point cloud system. This is the current point cloud from the project I have opened. And now I import the ones from the Faro project, from the GeoSLAM project. I don't need to change anything because the unit is meter and we use the dot as a decimal separator. So this is completely fine. We have the name, X, Y, Z coordinate. So we just press import. And now, as you can see here, the names are not in the correct lines because an identical feature in the reference system and in the point cloud system have to be in one line. So we know that we have the right constellation for the transformation. So I click just on Find Constellation. And now you see here, backdoor is backdoor, cellar is cellar, and front door is front door. And since I clicked them in a different order, you see that the names are not completely here are not correct. But since I named them, this looks good. And here you see the residuals. So we are here everywhere in around 1 centimeter to 2 centimeters in the different features. If we want to improve that, we have to go and look at the GeoSLAM scan, for example, and see if we can place the sphere a little bit better, or we can use more features. But at the end, it's about the accuracy of the transformation, right? And there we are, at 4 millimeters. And this is all right with the accuracies we have with the GeoSLAM scan and the Faro scan. So this should be fine. And to finish the transformation of this project, I just click on Apply Transformation. And then my complete Faro project is transformed in the point cloud system of the GeoSLAM project. And then both are in the same coordinate system. And all we have to do afterwards is combine them. Though all we need to do now, I can just press stop here because we don't need the views here, but let's wait for the standard top. So you can see that the coordinates are now identical to the GeoSLAM project and that both projects are aligned in the same way.
So you are going to export it into one point cloud file now, right?
Yes, that is the thing which we are going to do next. But I wanted just to show that now you can see that the project is aligned the same way as the draw project was aligned. And you see here the parameters again, that they are now big coordinates and not the small ones anymore. And I like to prefer to create a new project because then we are on the safe side. So we create a new project. Yes, I use the advanced importer here. Because then it's a little bit easier to see the different scans. So I will just place it here as well. So combined, save. And now I need to add the LSTX file, which is in the point cloud folder. So let's check that out. We have here the different projects. So let's start with the Faro scans. We have here the Faro scans point cloud folder, and in there we have an LSTX file. Just press on open, and then the scans are added, and we can import them by clicking on start. This time I won't wait till this is processed. I will just add the GeoSLAM files afterwards. So open the advanced importer again, do the same thing again, click on add. Now go to the GeoSLAM point cloud folder, take the LSTX file, open, start import, and now we have both projects combined, and that's all. We will wait shortly to process it, but then you should be able to see that we now combined both projects in, I guess I was very fast, so around 10 minutes. And this is directly possible with GeoSLAM Draw Start. So everybody who owns a GeoSLAM device is able to do directly that and combine Faro data with or data from any terrestrial scanner if you have the E57 file. So you're able to combine it directly if you own a GeoSLAM device. If you like to import other point clouds, like for example, the Faro project, the LS project, or you have a ZF scanner and you like to import ZF data, or you like to import recap data from which you registered in Autodesk Recap, you have to upgrade your GeoSLAM Draw to GeoSLAM BIM or Pro, and then you are able to import these as well. So now you see here, we have the outerior and the interior combined, and looks somewhat all right, I guess. So what we wanted to do and to show some new stuff as well, as Ivona mentioned. So let's have a look at this one, the view direction, which I will now show with this is not so good with the Faro data, but you can have that with ZEB Pano as well. So you see the view direction is showing in which direction I'm currently looking in the panorama, and this is very useful to get a sense of orientation with ZEB Panorama and know at what you're currently looking and in which direction on which wall in the layout view. Talking about other stuff, what we added in there is the vectorization. The vectorization is already working in there, as you know, but we improved it a little bit. So the auto vectorizer and so on is still working the same. But let me create here. We don't need the scans from the Faro scans here, so I just deactivate them and just let it calculate with the GeoSLAM data. No, we don't need this. So here we are. This is the basement, and what we have included now in the vectorization is when you create lines, you are now able to snap to these lines. When I press the Alt button, you see that there is a red cross now. So in this case, I'm able to create here the different line work very fast because I don't need to go in there completely and press here the correct location, but I'm able to just draw the lines myself with a button, and then I can just add them or combine them very, very fast. So you're able to get very, very quick your complete vectorized line work like you want to have it, export it as a DWG file, and then you are good to go with a plan. So this is coming with the next version of GeoSLAM Draw, which is hopefully out there soon when we have finished with the tests. Ivona, do you have anything else to add here?
Yes, one thing that is helpful here, as you were showing this vectorization or this automatic snapping into the walls, maybe reference to the accuracy. So when we talk about the accuracy of, let's say, Horizon or any ZEB system, we are in the range of 1 to 3 centimeters. But if you were just looking to measure the distance from wall to wall, and you really get the middle of the thickness of this wall on one side and on another, you are looking at the accuracy maybe within 1 centimeter of measurement.
Right. So this is
global. Yeah.
So this is one of the great things of GeoSLAM Draw, that you see that the pixels are shaded differently, as you can see here. And the more pixels are laying above each other, the darker we shade these pixels. meaning that your position where you should, of course, click is the darkest pixel possible, because normally noise in point cloud data looks like that you have points which are distributed. The most points are normally distributed directly on the wall, but you have some outliers, which are the noise, which are go out there into and outside of the wall. But since we have the most points on the wall directly, we shade the pixels there a lot darker, and then you're able to see that there we should draw the line directly. And with that, you can see that the snapping function is going into the middle of the line you see here. So I guess we talked for 45 minutes. Ivona, do you have more slides, or shall we start with answering the questions?
Just the last slides. We have the with the Revit output that your colleagues created, and maybe you can show the plugin here in Draw, and we can show that on slide.
All right, we can do both. So as I said before, we have the different packages, and with BIM comes a for Revit plugin. So you're able to connect GeoSLAM Draw to Revit directly and transfer the data automatically. And colleagues of mine, as you can see here, have used that plugin to create some output of that building in Revit, and have modeled that accordingly with the walls and so on. I have here the finished model as well. So you get a rough 3D model with the plugin directly from the point cloud, so you don't have the need to import the point cloud in Revit, but you can have the point cloud in GeoSLAM Draw like that, see the walls very clearly, and just use them to generate your walls, windows, doors, openings generally, and model other stuff in there. But it seems like you have here one more slide regarding reference plate and adjust to control.
Yeah. So since you talk, I don't know if you want to.
I'll give you the screen. Then you can use your mouse.
And Martin talked with the reference of using spheres to merge the scans. There is another option, or just to talk about another possibility of using the reference plate. So if you imagine that you have the surveying nails instead of the spheres that are difficult to look for in the point cloud data, you could put the system down with a plate with this cutout star, and if it's static for 5 seconds, it will record this position automatically. So this is more efficient when it comes to then merging the data or the collected points with the known control points and their GPS coordinates. And one of the features or new features in the near future that you've heard about would be adjust to control, that will later on allow you also in Hub to run the rigid and non-rigid transformation on the point cloud data.
This means that if you are using reference plates in there, you are able to improve the SLAM even more, because then the reference plate regarding the coordinates you have measured will be applied to the point cloud with a non-rigid point cloud transformation within Hub directly.
Yes, and for now, the reference plate could be used the same way with the same workflow as Martin showed in Draw, and instead of looking for the spheres or any other targets manually, you could just import the reference plate points that are automatically collected by this static period.
So there are many ways to get a combined point cloud project. Okay, let's start with the questions. The first question here is there an option to decrease the noise from the laser scanner?
Maybe I can take this one.
Yeah, please.
As we're zooming into the walls, you would have noticed that, of course, from horizon, that would be slightly thicker when compared to the terrestrial scanners, but we included an option in GeoSLAM Hub where you can run the smoothing on the point cloud. This is not getting rid of any of the points. It's just looking into points and their neighbors, and if they are supposed to belong to one wall or floor or the ceiling, it will smoothen the noise out. So this is within the export parameters. So there could be this extra step where you smooth the point cloud first and then bring it into GeoSLAM Draw.
Perfect. The next question is, what are the recommended targets and size of targets? Perhaps I take this one. As Ivona mentioned, the SLAM is looking for features in your object where you are walking around, and these objects need to be unique and bigger than 1 meter. So it's not about, normally you shouldn't be, or it shouldn't be necessary to bring your own features. Normally they should all be on site, but you will definitely see if there are no objects in your scanning location, like I said, cupboards, tables, boxes. I mean, even the suitcase where the GeoSLAM is in there could be helpful.
Maybe just one thing to mention, if I may.
Yeah, sure, please.
Also records intensity data. So if you have any checkerboards with a good reflectivity in near infrared, you could use those as well to pick the central point, and they are mostly used when horizon is mounted on the UAV for the airborne scan, for the roof scans, for instance. And for this, we would probably recommend the size of around 0.5 meter in size, but the targets need to be really well reflective, and you shouldn't be more than 20 meters away from them.
Yeah, if we add to that, if you want to use features, if you want to use spheres to combine projects, you can of course use normal spheres as well, like 145 millimeters or 200 millimeters. But they're normally bigger is better, because then more points are falling onto onto the sphere directly, and then of course you can estimate the middle point of the sphere a lot better. All right, next question. Will there be any option to have open loops in the future? If I know that correctly, you're already able to do that, but it's not recommended, right, Ivona?
Something that we will naturally work more and will be possible in near future. But for the best practice, to get the best results for now, would be to close the loops. But of course, with adding GNSS and more work, this would be the direction that we would like to, for instance, for ZEB Locate, to be able to scan assets more in a, let's say, linear capture rather than coming back for every single scan.
Perhaps I add one word to that. The issue with having no loops is that you're then completely relying on the IMU and very less on SLAM, because then SLAM can't close the loop and distribute the errors in your loop completely. So it's very easy to have a drift in any direction, because normally an IMU is not very steady. Even if you have a very expensive one, which costs where the IMU at least itself costs around 30,000 euros, the drift will be reduced, but it's still there. So a loop closure helps to prevent the drift there. The next question is, should aerial data be taken in loops or in stripes?
For the UAV scan, I can answer this one. In general, if you are trying to capture a big project area, we would say it's fine to capture in this grid pattern if you wish, as long as you probably fly within this limitation that we talked before, to around 200, maybe 250 maximum in a straight line from the operator, and this flight line spacing or the grid pattern should be done in a way that you have overlap, not as would be needed for photogrammetry, but that would mean that you would have, or you would be able to see the same features and have enough point density on those features in the middle of the flight lines in order to be able to, for SLAM to be able to recognize them and create a good trajectory. Nevertheless, if you have more like a linear scan project that you need to do, that you could maybe capture more in the loop area. Like if it's like a short part of the power line, then you could fly on one side of the power line and sort of fly in a loop back. Depends on the scan area.
Perhaps to give here a little background again, why you can't just fly in a straight line all the time. Yeah, you have no loop closure in a time, but the other thing is the IMU again is starting to drift, and an IMU is working better since it's an IMU, and IMU is measuring accelerations, so velocity changes. And if you have velocity changes, the IMU is working better. So if you just fly in one straight line, you don't have a velocity change. You are you have the same speed, right? So in this case, to reduce the drift again, it makes sense to don't have so long lines. The next question is again for you, Ivona. It's what type of GPS system can you use with ZEB Locate?
What you would have seen on the slides before, the GPS system was Trimble Catalyst, that we have the app for as well to record the data. But in general, you could use any GNSS-based system that you can get the data to the right format that we support. So we have like a CSV format of lat long information and accuracy information, and we will be also able to support NMEA data with the GP, GGA, and GST strings. So any receiver that can get you either NMEA or CSV file with required information should be suitable, as long as you can mount the system rigidly, like on the provided backpack, and have the known lever arms, XYZ offsets between the scanner and the receiver.
There was a specific question to the GPS which you can use. We will send you an email to that. All right. Next question. I don't know if you or I shall answer that. The question is it better to use a reference plates or spheres for referencing? Is one method more accurate than another?
Feel free to start.
All right. So if you use the reference plate, you have a very good accuracy with the GeoSLAM device, and you can do it in the field directly, so you don't have to search for the spheres afterwards in GeoSLAM Draw, in the GeoSLAM Draw project, in the GeoSLAM project. But so you need to search for the spheres, and you can locate them very, very good. The sphere localization in the FARO data is better than the localization of targets. This is because normally everybody is using GeoSLAM Draw Start and not upgrading to BIM or BIM, because with BIM you would be able to use checkerboard targets and localize them directly as well. So the middle point is estimated. But with GeoSLAM Draw Start, you have to use the 3D point feature. Perhaps I can show that very, very quickly. Let me just take over your screen again, Ivona.
Sure.
So now, as an example, let me just open here the scan location. If we would have here a checkerboard target in there, which we currently can't see. So let me just draw something. So we say this is our checkerboard target here. or perhaps I should just open a project with a checkerboard target. So now you need to locate the point with a 3D point tool by clicking in the middle point. And depending how well you click, it could be a good or a bad point. But when you upgrade GeoSLAM Draw, you would be able to use this tool here, and then the lines on the checkerboard target are used in addition to estimate the middle point. And then of course your checkerboard target is estimated a lot better. So in this case, if you have upgraded GeoSLAM Draw, then I'd say to use reference plates. But if you haven't done that, I'd recommend to use spheres, because then the spheres will be a lot more accurate in the data here, because you need to have a lot of accuracy in both in the Faro scans and in the GeoSLAM scan to get the best result.
Yes, and as Martin mentioned, because the complication can be if you have different teams of people, so a surveying team and the processing team. So it does make it easier if you don't have to then look for all those control points in the data manually. But spheres in theory could be more precise, right?
Okay, perfect. Next question. Is it possible to import the Pano pictures with the BIM extension for Revit and work on them to identify windows, doors, etc.? So this is a very good question. In theory, this would be possible. In practice, we are not satisfied with the results we are getting there for the point cloud in the background. So measuring in the images is possible, but the accuracy is not so well. So you won't be able to get the accuracies you need, or you want normally from the Pano images. So currently we are not able to give the accuracies and handle the data well in that regard. We are currently looking at that, if we can have a better workflow for that, for the integration of both.
Yes, Pano is more for us as a visual reference. So I guess you could have it open in Draw with Revit plugin, right, and see sort of where you're looking at, but it's mostly for visual reference. Discovery is the next system with a 360 camera on the top with horizon. That does allow you to align the images together with the point cloud. But perhaps that's not the best system for the Revit application.
Okay, next question. You show this case, compare GeoSLAM to stationary scanner. As I get, you make that building at once and I may miss that, but what was maximum deviation of error? Or maybe you can say, what is maximum suggested length of scanning with horizon to stay in below 5 centimeter error on full dimension? So as we discussed before, prior, the accuracy on the GeoSLAM device and on a terrestrial scanner can be identical. I mean, it's completely depending on your scanning grid, how you place your terrestrial scans, and of course, how you walk around with your GeoSLAM device. What we did here is, or we did a test here as well in this building, and what we did is we walked around this building, only this building, for 20 minutes. And I don't know how many loops we did by walking around there, but we made a bet if the GeoSLAM device would start to fade away and the walls wouldn't be aligned anymore at the end, or they would. But to my surprise, because I bet it wouldn't, they wouldn't align, they were perfectly aligned afterwards. So the more loops you're able to close and see identical regions again to make loop closures, then you should be able to get the 5 centimeter basis. But of course, it's depending on a lot of different things, like how is your your environment. What are you scanning? What are your distances to the locations which you are scanning? Are you outdoors, indoors? So there is no base rule for that. And it's always very complicated to compare two point clouds to each other in regards to accuracy, because you can compare the spheres, for example, that you say, okay, here I have a sphere here and a sphere there. What's the difference there, or what's the aberration? But then you are only looking at one small part of the point cloud and not at the point cloud as a complete point cloud. But if you, for example, try to compare the point cloud as a whole by using a point-to-point algorithm, then you have other issues there, because the distribution of the points are not completely at the same space in 3D space. So I dislike comparing point clouds to each other. Next question for you, Ivona. For corridors mapping, how long you should suggest that the corridor should be?
I think the same practice applies whether it's Horizon or the Revo, that you would need to make some loops. So if it's a, let's say, corridor of 50 meters long, that's fine with Horizon, because we would say that you can easily walk 100 meters straight and then make some loops around the features. If it's Revo or the Revo RT system, we would say you should not walk more than 30 meters in a straight line and then make some local loops around. Saying that, corridors, if it's like a new build or if it's empty, you should have some features there at least every 10 meters in distribution. So if you have some cardboard boxes, if you can bring some furniture, chairs in there, that will help with the scan. Or even if you have some rooms that you can pop in but necessarily don't need in your scan, something to think about and make a loops there, as that will just improve the overall accuracy of the scan, making those or making use of those environments where you can make the loops. And if it's just straight, maybe around the box or the couple of chairs, just make a smaller loop every 30 meters with Revo and every around 100 meters at least with Horizon.
All right, thanks for that, for the answer. There are no more questions currently, so thank you for attending, everybody. If there are any other questions, you can just contact us. Here are our email addresses, or you can just go to our websites, and there you will find a contact as well. And then we can answer other questions. Or if you want to have a web demo of what you can do with Draw as well, or other things, just contact us. And thanks for attending.
We'll be happy to answer anything. Thank you, everyone. Thank you, Martin.
Thanks, Ivona, for having the webinar today. And bye, everybody.
Goodbye. Have a good day.